In some cases, it might be necessary to expand or contract before you can solve. So because we have two of the same log on the same side, we're going to condense these two logs into one log. So this is going to give us just log base 2. And then because those two logs are joined by an addition sign, we still have the x and the x plus 6 that we need to take care of. And when you add logs together, you multiply what you're taking the log of. So this would be x times x plus 6. And then we still have the equals 4 over here. So you have two different options for this. You can rewrite this in exponential form, or you can take this base here and turn this into an exponential equation. So we're going to do 2 as a base on both sides. So this log base 2 and this 2 are going to cancel each other out. And we have 2 to the 4th over here. So 2 to the 4th is equal to 16. And on this side, we're just going to distribute. So x times x is x squared. X times positive 6 is positive 6x. And because this is a quadratic, in order to solve any quadratic, we need to make sure that our equation is equal to 0. So we're going to subtract 16 from both sides, and I'm going to put it in between the x and the equal side here. So I'm just going to put that little arrow to show where I'm putting this. So over here we have it equal to 0, and on this side we get x squared plus 6x minus 16 is equal to 0. And now you have two different options. You could either factor or you could use the quadratic formula. And in this case, we can factor this, so that might be a little bit quicker. So we're looking for two numbers that multiply to negative 16 that add to positive 6. So I'm going to put our x's in here, and they're both going to be, one's going to be positive and one is going to be negative. So we have a positive 8 and a negative 2. And now we need to use ZPP to solve these two equations here. So x plus 8 equals 0 and x minus 2 equals 0. And to solve this one, we subtract 8 from both sides, so x is equal to negative 8. And on this one, add 2 to both sides, so x is equal to positive 2. And then the last thing we need to do is look for extraneous solutions, and those are solutions that look like they'll work, but in the long run don't actually work. So if we go back up to this original equation up here, if we put a negative 8 in for both of these x's up here, we would be taking the log of negative numbers, which we know from a previous lesson is undefined. So x equals negative 8 is not actually a viable answer, but if we plug 2 in, we're taking the log of 2 and we're taking the log of 8, and both of those will work. So our only answer is x equals 2.